Okay, let's consider the circuit that is shown on the screen here. Now, just like we looked at in the inverting amplifier, we could analyze this circuit. So the voltage at the non-inverting terminal is 0, and because of the ideal op-amp assumptions, the voltage then at the inverting terminal is also 0. Now, if this is 0, we know what the current is that is flowing through this feedback resistance. Let's call it IF. Okay, we can calculate it, and then this current IF is going to be the sum of the currents I1, I2, and I3, right? So I can write IF equal to I1 plus I2 plus I3. So let's write what IF is going to be. What is IF going to be? It is going to be 0 minus V out divided by RF. So it's basically going to be minus V out over RF. And similarly, the current I1 is going to be V1 minus 0 over R1. So it's basically V1 over R1. And similarly, I2 is going to be V2 over R2. And then I3 is going to be V3 over R3. And therefore, we can write V out equal to minus RF over R1 V1 plus RF over R2 V2 plus RF over R3 V3. Now you can see what this circuit is doing. This circuit is basically doing a weighted sum of V1, V2 and V3, right? If you have RF equal to R1, and let's say R2 and R3 are also the same, that is, all the resistors in the circuit are the same, then what we get is V out equal to minus V1 plus V2 plus V3. So this circuit is basically adding up voltages V1, V2 and V3, and the adding can the weights of the adding depends on the resistors RF and R1 and R2 and R3. So this circuit is called a adder circuit. Okay, just because it's adding up signals.